And I have everyone admitted who wants to get in the class, so let's go ahead and get started. So again, I'm your professor, I'm Randy Kearns, and this week we'll talk about introduction to research, and we'll continue to work through the presentation that we did last week. I do want to offer a couple of insights into the class, things that are due this week and things that will be due in the coming weeks. If you've had a chance to, and hopefully you have had a chance to review what's in Moodle, you'll see that there's some group activities coming up. We will formally break up into groups the first night we have class, which I think is set for the 22nd of February. No, I'm sorry, the 23rd. So we will be in the classroom on Tuesday evening, the 23rd of February, and the 23rd will be two things. Number one, you will do a short PowerPoint presentation that talks about your research question, and number two, we'll break up into groups. And when I talk about groups, what I have in mind are kind of broad topics. Hang on just a minute. There's a few people in the waiting room. Okay, so again, when I talk about groups, there are broad topics that I've listed as potential topics. If you choose a topic that would fit under one of those headings, you'll wind up doing a couple of group activities within whatever that group winds up being. It could be one person, but it's more likely to be 4 or 5 or 6. But the point is, a majority of your effort this semester will be things that you do yourself, developing your research question and developing your research. And so while there will be some group activities, primarily and by and large, your grade will center around your effort. And I'm sorry, I'm just trying to be sure that I don't miss anyone trying to get into the class. But again, your grade will center around your effort, specifically your research, and then your conclusions, what you wind up writing up as your final paper. And so as we go through this, just keep that in mind. So let me give you some examples. Let's say two students, one's named Joe and the other one's named Alice. Joe wants to do something related to sexual assault on campus, and they want to look at what the historical data are at the University of New Orleans and maybe compare those findings with other universities in either New Orleans or other universities that may be our size. And quite honestly, you could, just in saying that, you could wind up breaking this off into 2 different research topics where one person is looking at comparing the University of New Orleans with Tulane, Loyola, maybe Delgado, but Xavier. But the point is, you could look at comparing findings of what's going on at UNO compared to other universities here in New Orleans. Somebody else could be comparing what's going on here in New Orleans to other large city universities, such as Memphis University, previously known as Memphis State, or Charlotte, the University of North Carolina at Charlotte, Georgia State. Those are city universities that are in large cities, somewhat similar in size to that of New Orleans, and may also have some similar experiences. You can also look at specific programs related to how do we provide peer education to help people understand the challenges associated with prevention of sexual assault, and being sure people understand what sexual assault is. Um, sometimes if you've never been, if no one's ever really uh, invaded your privacy, so to speak, sometimes you don't exactly know where those lines are that are crossed, and just understand that it's far more likely that there are sexual assault cases that go unreported than there are sexual assault allegations that are unsubstantiated. Again, far more likely to be underreported, and because it's more likely to be underreported, it is important for us to certainly be self-aware of that, and certainly look for opportunities to provide education so that other people know what those threats are. Again, the University of New Orleans is a reasonably safe university, but it's just like any other university setting at some level where there's always some relative risk. And I focused on sexual assault. Certainly we could talk about vaccine use, do vaccines, what's personal knowledge associated with the vaccines. Somebody could focus on the COVID-19 vaccine, and there's, again, thousands of research questions you could develop around the COVID-19 vaccine. The flu vaccine, again, thousands of questions you could develop around it. It's really about taking a broader topic, such as, again, sexual assault or vaccines or tobacco use or mental health services, but taking one of those broad topics and then narrowing it down to make it a measurable research project that you're interested in. Because quite honestly, if you're not interested in it, then all we're doing is a meaningless academic activity, and that's not fun. It's certainly not exciting. And what I want you to get out of this is I want you to be able to understand the methods associated with research, but I also want you to hopefully share some information, build some knowledge, and again, walk away from this with maybe a much larger research paper that, who knows, in 3 years or 4 years, you use as the basis to develop your master's thesis if you want to pursue a master's degree. But again, the key things that you need to do this week includes developing your research question. And so let's kind of move through this just a minute, and I will come back to this one more time before we finish up for the evening. At one point, I had included something about a research project going on at Tulane that went on last year. They told us it was going to continue this year. Obviously, because of the pandemic, that project has been suspended at the moment. I don't, if it does become active again while we're still in this semester, then certainly I'll get back in touch with you. But right now it's not available. But I would offer that as an opportunity for extra credit. And I will look for opportunities for extra credit to also help broaden your research experience. So again, we'll have the presentation for tonight. I'll go over that information in just a minute. ResearchGate, I noticed, I think about 7 of you so far have gone into ResearchGate and completed a profile. Again, the advantage to ResearchGate gives us an opportunity to actually track down the author of papers that we may be interested in. If you want to know more relevant information, it gives you an opportunity to reach out to them and ask them questions. It really creates kind of a grassroots effort so that you can see that information. Now there are a couple of other locations that we will find good research. One of them is PubMed, and another one is Google Scholar. And we'll also talk about other resources again Tuesday night, the 23rd. But right now, I would like for you to get a ResearchGate profile and go ahead and get a screenshot of your profile and post that to get credit for that assignment. UNO ScholarWorks is also a place that we will find some of our research materials. And again, I'll talk about this a little bit more later on. There may be some obscure article that you're really interested in trying to track down. If we don't have access to it through the University of New Orleans, I still have my academic access. I'm a retired professor from the University of North Carolina at Chapel Hill, and so I still have access to the UNC system, and it's a little bit more elaborate than what we have with the U of L system, but it certainly gives us one more option. If all else fails and you're not able to find a resource, contact me and let's see if there's another option out there. I did include, so I've included a couple of links here of what good research is, and certainly what bad research is, and what some troubling research is. As we get closer to the end of the class tonight, if we have a little bit of time, I may show a couple of these. The Writing Center, also at the University of New Orleans, has, if you have any types of difficulty with writing, just understand that there's a writing center at UNO that's dedicated to helping you put things together. Again, some of you may have never written something quite this elaborate. And what we're going to wind up doing is each week we're going to have assignments that help us build up to what that final paper will look like. And each week you'll have small pieces of assignment that, again, as we accumulate more and more small pieces, will build up to a large paper that's due at the end of the semester. So, and then the only other thing that's due this week will be a quiz for sections 1 and 2. And so let me go back over that one more time. The assignments you have due this week, you need to get a ResearchGate profile established and give me a screenshot of it. And the second thing is to complete the quiz. Okay, those are really the two things that are due this week. Now, I mentioned talking about the question, and I mentioned talking about getting started with research. If you look at next week, your assignment next week will include developing your research question. But don't wait till next week, particularly don't wait till Sunday night a week and think, oh my gosh, I've got to have a research question. Please do something about that before now or before next week. Please, please go ahead and plan ahead and think about that this week. If you go ahead and put your question together, that's great. Go ahead and submit it. Again, the whole point to this is to be sure that you get a chance to get some of these projects done and to get some of this started. It's going to be a lot easier to develop the content along the way if we start out with a good question. And chances are your first attempt at a question, a research question, will require some adjustment. You'll submit something and I'll look at it and say it's too broad, we need to, and I'll give you a couple of options. But that's, again, that's the nature of understanding what good research is and how we develop good research habits. And I think that's it for the assignments for this week. Again, the assignments this week, a ResearchGate profile and complete the quiz, but I would encourage you to go ahead and look at what the assignments are next week and go ahead and get started. And one of the first places I would get started is to start thinking about what category you want your question to be in and what type of question you want to put together. And certainly if you have any question, if you're uncertain about how to put together your question or you want to run something by me, just send me an email. Again, I may not be able to get back to you immediately during the day, but in the afternoon or in the early morning, I'll certainly get back to you as quickly as I can. And if there are no questions, let me go ahead and get started with the presentation for this week. Let's see. So this is what I have. Let me change the screen I'm sharing. Let's do that and then share screen 2. Okay, so just to be clear, is the screen you're looking at, is that the one with the presentation full screen?
Yes.
Okay, thank you.
Yes.
And actually, let me move over to, I think it's going to be about slide 29. Okay, so section 2. With section 2, again, our key terms, data is the plural of datum. What's the difference between data and information? What really has caused research to explode in such an extraordinary and meaningful way? And it really comes down to big data. It also comes down to computer processing capabilities. One thing that, from time to time, I hear people talk about, well, I'm a little concerned about the vaccine because they developed it so quickly. Just understand the difference between developing a vaccine today in 2020 or now 2021 and developing a vaccine 20 years ago is we understand in a far more finite way how to genomically sequence a virus, in this particular case, a very small, very specific virus, and then build a method to deliver a protein to cause a human to create an antibody that would combat that. And so an mRNA technology has existed for many, many years. It's just never been, it's always been too expensive to use for vaccines. But because the federal government offered these pharmaceutical companies a large amount of money to develop vaccines, they had the money and certainly had the technology to use mRNA technology to develop vaccines. But all of that comes about through big data, and it comes about through computing processes in a way that we've never had that capability in the last 10 years, the last 15 years. It normally would take us, in some cases, 3 to 5 years to develop a vaccine, or 3 to 5 years to understand why we couldn't develop a vaccine. HIV is an example. It took us years to understand why we were not going to be able to develop an effective vaccine for HIV. We don't really have time to go into the nuanced details of it, just to understand today we have a far better understanding of the fact that it's very difficult to develop a vaccine for everything, and HIV is one of those. But what we developed through the years, and that's always that twofold side of research, is you certainly want a vaccine. Vaccines are the best way to prevent viruses, but you also want effective treatments. And even though we haven't developed an effective vaccine, because we now, again, genomically understand the composition of the virus and what are ways that we can either isolate the virus or do our best to rid the body of parts of the virus, we have effective treatments today that in 1986, if you were diagnosed with HIV, you were told to get your affairs in order. You basically had a lifespan of between 3 months and 1 year. Very few people who were diagnosed with HIV in 1986 lived to 1988. And that's just not the case today. Today, if you're diagnosed with HIV today, as long as you're diagnosed early and as long as you take your meds, you can live an otherwise healthy life with a reasonable lifespan that's comparable to that of anybody else. And so all of that comes about, though, through big data, and it also comes about through computing capabilities in a way that we've never had before. But all of our research really starts with a good question, and the good question is specific, it's targeted, and sometimes it starts out in a general approach, but then I have to think about how I want to take that question and turn it into a specific approach. And so let me give you an example of a question. If I want to know, if I'm trying to create a computer model for how we would manage a significant number of patients who have been injured with a burn injury in the southeastern United States, then my question would be, what is the capacity of the American burn hospitals in the southeastern United States to manage a mass casualty incident? So that's a question, and I've targeted a specific area. I can, in a quantitative way, I can count how many beds are available. There's data out there that will tell me what the capacity is. So as an example, if my capacity is 15 beds in a burn center and my average daily census is 12 beds, then 15 minus 12 is 3. So I've got room for 3 patients on average every day, 365 days a year. Well, if I do that calculation for every burn center, and then there's some other factors to consider, I can come up with theoretical models of what we could absorb if there was some catastrophic event. But the other thing it tells you is, in a more finite way, also know at what point I break the model. As an example, that's actually my doctoral dissertation from 10 years ago. And that mathematical model, I used a computer simulation tool called At Risk by Palisade. It uses Monte Carlo simulation. And what that does is I set it up for 10,000 iterations, and it looks at the problem in a multitude of ways. And at some point, you're going to break the model. And at what point you break the model, it tells you beyond that, no matter what the number is beyond that, we're not capable of managing that in our traditional standard of care mentality. In other words, think about the pandemic today. At one point, we were taking care of patients in the convention center. We built that system so that we could take care of up to 2,000 patients in the convention center. Just understand, and we may call that a disaster hospital or a field hospital, but please, there's a substantial lack of services to really call that a full-blown hospital. But what we were doing was creating surge, additional places that we could put patients until we could either get them in the hospital, or once they left the hospital, places that they could go to if they didn't have a safe place they could go home, or they needed to convalesce and further recover, and we needed the more acute bed in the hospital. Well, we built a capacity here in New Orleans. We built a capacity, at least on paper, to be able to manage up to 4,000 patients. And that was because of our concern that this would get out of hand. And so anytime we're dealing with disaster surge capacity, you've got to first quantify what your real number is that you can manage every day, and then look for how you build excess capacity. Well, any of those mathematical models start out with a question. For me, I created a question that dealt with the capacity of burn centers in the southeastern US. You develop a hypothesis. If there's an event that produces 400 patients, then we will be able to manage all 400 patients with a traditional standard of care within the southeastern region of the United States. The null hypothesis is, if we do that, we won't have the capacity to do that. And I want to test it for both the hypothesis and the null hypothesis. And at some point, there's a theory that develops out of that. And all of this moves through the scientific method. Now, these pieces about descriptive, historical, correlational, qualitative, true experimental, and quasi-experimental, I'll cover later on. Blinding in samples, population and census, and statistical significance, I'll also cover in just a minute. But again, all of these are important terms, and you need to know these terms. You will see them again, both in the quiz coming up as well as other quizzes that you may take in this semester. These are some of the most important terms you will see that's a part of research, okay? I've said that, and I've underlined it, and I've bolded it in yellow, so please understand these are very important terms in the world of research. So again, back to the question, what method did you use for your research? And we'll go through a couple of types of methods. Part of it depends on how precise you want the measurement to be, or how precise you want this to be. Non-experimental research creates relationships, but it doesn't test cause and effect. And an example of non-experimental methods, descriptive numbers. Let's talk about descriptive numbers. So if I'm sitting at my desk at the University of New Orleans and I look out into the parking lot and I counted all of the cars in the parking lot, that's a descriptive number. If I counted all of the blue cars in the parking lot, that's a descriptive number. If I counted all of the red cars and the black cars, or if I counted the cars versus the trucks, all of those are descriptive numbers, and all of those are non-experimental methods, but that's what descriptive research is. It's basically a count of whatever it is you see and whatever it is you want to measure. Historical research may be, okay, so I count all of those cars today. Next week, I count them again. Next week, I count them again. And I look back over 3 weeks to what the historical numbers have been. Historical numbers give us an idea of how things evolve. In fact, there's something called longitudinal research where we plot things out over time, and it starts with a historical marker. Anytime I'm writing an academic paper, and again, when we start looking at PubMed, you'll see that I've published a lot of papers. I have spent a lot of time as a researcher. I like to start a lot of my papers with some type of historical reference that basically is my stakeholder, or my placeholder that sets a stake in the ground and says, I'm going to start at this point and move forward. Okay, that's my idea of historical research. And then the correlational part is to look to see if there is some correlation between two different items or more, 2 or more items. Qualitative research is difficult to do. Sometimes we try to take qualitative research and turn it into a quantitative measure, but let me give you an example. I don't like pain at all. Okay, I am not a person who, if you hurt me, I'm gonna pass out. Okay, I've done a lot of skiing in my life, and I was snow skiing many years ago and broke my leg and was in the hospital, and they were putting a cast on my leg, and the nurse asked me if I had any history of any type of medical condition, and I said no. And at some point, I remember waking up, and anyway, they're in a bit of a, she said, I thought you told me you didn't have any medical histories. And I said, well, I didn't think you were going to hurt me to the point that I passed out. But it's the whole point to that is that's a qualitative measure. My idea of pain may be completely different than your idea of pain. What is a 10 on a scale of 1 to 10 for pain for me may be different than it is for you. That's qualitative research. Now, what we do by trying to convert it into a numerical scale is to try and turn a qualitative measure into a quantitative measure. but just understand qualitative is subjective. It's what I feel, it's what I think, it's how I perceive things. And because no two humans are exactly alike, exactly what I feel and what I think about something may be different than what you feel or what you think about something. Again, qualitative is subjective. It's how I feel, how I understand, how I perceive, as opposed to things I can count and measure. I can count how many cars are in the parking lot at the University of New Orleans. That's descriptive. That's very easy for me to do. I can't tell you how someone feels about their car being in the parking lot at 9 o'clock at night. Uh, Actually, I probably can. They're probably dismayed because they want to go home. But again, that's descriptive research. Gives us a broad picture. The historical research typically gives us some type of placeholder where time starts in the element of how we're going to describe our paper or how we're going to describe our research question. Correlational research, again, looks for some type of cause and effect or what type of events are in common. Again, correlation does not assume causality. So just because you can correlate something doesn't mean there's a cause associated with it. As an example, I don't know, let's say someone in class tonight parked their car at 5 o'clock today. Well, at 5 o'clock today, I opened this can of sparkling water, okay? So there may be some correlation between the fact that 5 o'clock most days, I may be opening a new can of sparkling water. And at 5 o'clock most days, you may be parking your car in a certain parking space. That may be correlation, but there's no causation. Just because I open the can of sparkling water doesn't make you park your car. So there can be correlation, but typically correlation does not always imply causation. Anyway, and then again, qualitative research is subjective. It deals with social issues, cultural issues, certainly political issues. The real challenge with political issues today, again, there's so much passion involved in it. It's very difficult for us to look at things in an objective fashion. Anyway, that's a great example of qualitative research. And then the experimental research, there's really two types, true experimental and quasi-experimental. With true experimental, we can assign participants to groups and control those groups. And I'll give you some examples of that in just a minute. With quasi-experimental, I can't really pre-assign the groups. And sometimes I can't manipulate the variables because there are participants are already in pre-assigned groups. So let me give you an example. Let's say I want to compare your scores on a standardized test to the scores of Dr. Zimmerman's class on a standardized test. Well, we're not going to change students. I'm not going to send some of my students to his class and some of his students to my class and then randomly select students. Those groups are pre-assigned. His class is pre-assigned and my class is pre-assigned. So we can't manipulate those variables, but we can give each of the groups the same standardized test and measure the capability of the group that he's teaching versus the measure of the group that I'm teaching. So again, that's quasi-experimental. Again, if it was true experimental, we would randomize who went to his class and who came to my class. That type of randomization is also, there's different levels of randomization, and in those cases, we call that blinding. So with a single blinded case, so let's use the vaccine as an example. I am participating in a clinical trial right now for the COVID-19 vaccine. I participated in what was considered a double-blind trial. And with a double-blind trial, so with a single-blind trial, if I go into this office, they randomly select a group to get the vaccine and a group to not get the vaccine. If it's single-blinded, I don't know if I got the vaccine, but the person giving the vaccine does. Okay, that's single-blinded. Well, a double-blinded trial, and actually the one I participate in is a double-blinded trial. They didn't know if they gave me the vaccine or if they gave me the placebo. And I certainly didn't know if I got the vaccine or if I got the placebo. Okay, that's double-blinded. In fact, there's control numbers that allow somebody that's not located in New Orleans and not participating in the trial, they know, but the people working at the doctor's office or at the place where the clinical trial is being conducted, they don't know. You can also create a triple-blinded trial that creates another layer of protection. Again, the best research design is prospective, meaning we design the study and we look forward and we develop the study going forward, and it's at least double-blinded, meaning there's multiple groups that are not aware of what's going on. And so that's the best study design. Now, recently I had the opportunity to take the vaccine, and because I had that opportunity to take the vaccine, actually a different vaccine, the Moderna vaccine, I was able to call the office where I'm participating in the clinical trial, and they opened up my file and were given access to the full information and told me that I actually was vaccinated in November of last year with the actual vaccine. So they don't want me to take the vaccine. They don't want me to take another vaccine. Again, we have very little information about how effective two vaccines are right now. And so therefore, we want everybody to take one vaccine, but not two different vaccines, at least not yet. Anyway, the non-experimental, so here's a summary of the 6 research methods. The 4 non-experimental include descriptive, historical, correlational, and qualitative. The 2 experimental designs are true experimental and quasi-experimental. And again, the true experimental, as the controller of the experiment, I can randomly assign people to different groups. Quasi-experimental, I have to accept whatever group they're in, and I've got a group A and a group B, okay? And then the non-experimental is more likely what we're going to do as a part of our research project. It's the easiest thing to do, and it gives us a chance to use a lot of what's called secondary data, meaning information that somebody's already collected for a different reason, okay? Again, what method do you use and when do you use it? This is a good chart that's a decision tree. Again, do you want differences between the groups, and are the participants pre-assigned? This really helps you which type of group you want. Obviously, the best research is true experimental design. We don't really have the time and the effort and energy to do that. We're going to probably do something that's more likely to be non-experimental, although we'll do a small controlled experimental research project within our groups. Again, something we'll talk about later. And of course, provided the pandemic doesn't interfere with that activity. The last time I taught this class, we were in the middle of doing those group projects when the pandemic shut down the school and obviously ended those projects. Other pieces that I want to be sure and talk about tonight: basic versus applied research. Let me kind of give you an example. If you work in a if you're in science and technology and you work in a lab, a basic science lab, you may test a certain piece of metal as it reacts to different types of things being applied to the metal. And you may do that and report the observation 500 times, maybe 5,000 times, depending on how many different variables you introduce to that piece of metal. You're not really producing anything other than lots of basic science. There's no immediate application for that, but let's take that a step forward. Let's say I want to take that piece of metal now and I want to put it in a lithium battery, or I want to put it in a solar cell. Because of all of the basic research that's been done, I now don't have to go through 500 steps or 5,000 steps to figure out if this piece of metal will work in this environment. It's already been tested in basic research. Now I get to assemble pieces that have come from the basic research side. That's called applied science, okay? It's when we assemble things from the basic research side into hopefully a functioning product or some type of an application. Solar technology comes immediately to mind because I have a daughter who is working on her PhD in chemistry, and that's a part of her research, was testing different elements that would wind up going into solar cells. But again, her basic research was actually in one particular evolution. They spent the summer doing 10,000 tests associated with one particular type of metal. But again, that basic science is needed to push forward our applied research, but we've got to have basic research to create the applied research. Another aspect of this is variables. Variables are outcomes, and the more precise a variable can be measured, the more useful the measurement is. And so an example will be if I'm trying to drive from my home to the University of New Orleans. What are the variables? Well, the variables could include the traffic between here and there, the conditions of the road between here and there, the type of car that I drive between here and there. All of those variables, though, in some cases I can control them, in some cases I can't. And so a part of this is to measure what types of outcomes are produced as we manipulate the variables. With dependent variables, it is the outcome of the research study. It does depend on the experimental treatment, and it's really what you're interested in. As an example, if the outcome of my research study is to figure out how long it takes for me to drive from my home to the University of New Orleans, that's really the outcome of my study. That's my dependent variable. And the experimental treatments include maybe taking different routes to get there. It may include, do I drive my wife's vehicle or my vehicle? But those are the experimental treatments. Do I leave at a different time? Does that make a difference in being able to drive there in a shorter period of time? But again, what are we interested in? And then the independent variables are the things that are under the researcher's control. And then what are the independent variables allow us to manipulate some of those changes. There's other things that's commonly found in the literature, a control variable and an extraneous variable. I include those here and I include them in the chart just to help you understand that there are two other variables that may also be considered. But to be quite honest with you, the two most important variables include the dependent variable and the independent variable. And then what makes a good hypothesis? So now we've moved into, again, getting back to how we use our hypothesis and how we take our question and develop it into a hypothesis. We state it in a declarative form. Now I will tell you that I like to create a relationship between variables. And although it's a little bit old school to do it this way, not everybody teaches hypotheses in an if-then proposition, but I still like to use if-then because there's a certain basic simplicity to it that's a little bit easier for some people to understand. If I turn this light switch, then the light will come on. And so helping people understand the relationship between a hypothesis and an outcome helps people develop theories and understand how theories are developed, and also understand the really basic component of a hypothesis. And one of the most important things about a hypothesis is to be sure it's testable. So if I turn this switch, then the light comes on. That's my hypothesis. The null hypothesis, if I turn this switch, then the light won't come on. Well, if my null hypothesis proves true, either way, that's testable. If my null hypothesis proves true, that may mean a couple of things. It may mean this switch has no relationship to that light. It may mean that light has the bulb burnout in it. There could be lots of reasons why my hypothesis was not proven true, why the null hypothesis wound up being proven true. But the whole point to a hypothesis is it's got to be tested. And I get back to my question. Does that switch control that light? That's my question. And the best way I convert does that switch control that light into a hypothesis? If I turn that switch, then that light will come on. And so it again, we move from a question to a hypothesis, and then to a theory. And the theory in that will be most lights are controlled by light switches. And most light switches, my theory is most lights are controlled by light switches, and most lights that are controlled by light switches, the light switches within a very close proximity to the light. Okay. Again, I know that's a really simple approach, but the whole important aspect of this is just so you get the grasp of moving from a question to a hypothesis to a theory. And for the purpose of our research, we've got to develop a question first and then learn how to state that in a hypothesis. So let's also talk about samples and populations. So if I want to know, first of all, the population of the city of New Orleans is about 400,000. Okay, it's probably a little bit less than that, but let's just say for the sake of argument, the population for the city of New Orleans is 400,000. Well, how do I know what that is? Somebody had to count that. Okay, when you count a population, counting a population by definition is called a census. Okay, everybody in a given area, or all of the pieces in a given research project, will be your population. Okay, typically we think about population in terms of people. So all of the people enrolled at the University of New Orleans, that's the population. Well, how do I know what that population is? Or all of the people who live in the city of New Orleans, that's the population. Again, how do I know what that population is? They've been counted. And when they're counted, that's called a census. Well, if I want to know a question, if my question is, how many people in the University of New Orleans are live on the West Bank, and do I have to, let's say there's 8,000 students at the University of New Orleans. Do I have to talk to all 8,000 students to be able to come up with a reasonable idea of what the percentage of people from the University of New Orleans live on the West Bank is? And the answer is no. But I do have to identify a representative sample. I've got to identify a sample that gives me some representation of the total population. So I don't have to talk to all 8,000, but I may need to talk to about 200, and I may need to pick a representative sample. And a part of that is identifying what the statistical significance of 200 is as it compares to 8,000. But the whole point of what we really want to talk about right now is I don't need to count. If I have a count for everybody, that's my population, and the actual function of the count is my census. Okay, but I don't need to count everybody to get a representative sample. A representative sample is a smaller group that gives me statistical significance. And so what is statistical significance? It basically allows us to look at smaller groups that still infer the type of numbers we would expect from the larger group. Again, if I want to know, a part of the challenge with New Orleans is the city from neighborhood to neighborhood is dramatically different. Life expectancy in one zip code versus another zip code may differ by as much as 20 years. And that's substantial. That tells us about the endemic problems. It tells us that there are endemic problems in certain zip codes in our city. There's tremendous life expectancy issues for groups of people who live in certain communities. Maybe it's more dangerous. Maybe they have less access to good food, meals, the types of things that you need to be able to have a healthy life and to live a long and productive life. But again, I can't just look at one neighborhood and from that one neighborhood extrapolate to the entire city of New Orleans. To develop my statistical significance, I'm going to have to look at multiple neighborhoods. So it is important to understand how you acquire statistical significance, but a part of that comes from finding representative samples of all of the represented communities. And then one of the last things that we're actually, so I've got a separate presentation that we won't go over tonight, but it does deal with what something's called an institutional review board and getting IRB approval. If we did something more elaborate, again, our survey design will be designed in a way that we will not collect particularly sensitive information, but an IRB is necessary for certain types of research. Again, because of the window of time that we're functioning in, we're going to avoid trying to need an IRB. But each university, each hospital has an institutional review board, and that IRB is there to also create safeguards and things that we do. Again, I've got a separate presentation about the value of an institutional review board and how they help set safety barriers for us to assure that we don't go outside of those safety barriers. And we will go over that before we actually set up and conduct some of our research. And with that, that kind of takes us to, again, what is this research all about? What are we trying to do? The whole point that I want you to be able to take away from this class is understanding the methods of good research. Again, by the time you leave the University of New Orleans, you may hope that you never have to write another project this size and this complex. But by the time you leave the University of New Orleans, I do want you to be confident in the fact you can write a research project of this size and this complex. And what good research is to help you understand also what good research is not. The more we understand those things, the better off we're going to be. Again, whether you wind up in business and industry, or you wind up in quality, or you are writing these types of reports the rest of your life. But even if you're not, you need to at least be able to read one and understand what it means and how it may affect you. And with that, let me go ahead and stop sharing that screen and go back to go back to sharing. Let's see, screen 3. And let me put that down on the taskbar and go back to Moodle. So again, let me be sure and recap for tonight before I turn you loose. You have 2 primary things that are due this week: the screenshot of your ResearchGate profile and the quiz for sections 1 and 2, the basic research. Please have a really good understanding of those terms. And I also don't want you to feel like once you see those terms in this quiz, you won't see those terms again. You will see them at other times during this course, those are very important terms. Those are really the fundamental basics of research. So those are the two key pieces. I'm not going to go over it. Well, actually, so the Milgram experiment, Willowbrook, the Tuskegee syphilis study, and the Milgram experiment short, all of those are real events that have occurred in the history of the United States and have occurred under the aspects of research. And quite honestly, should remind you that not all research is good research. And in fact, in some cases, it destroyed lives, it hurt people, it left people in less than well beyond difficult situations. And so I can't tell you enough the importance of having safeguards on our research to be sure that what we're doing is both ethical and just for the people that are involved in the research, and the means doesn't justify the end, or the end doesn't justify the means. So again, I would encourage you to look at those when you do your discussion question next week. You'll have an opportunity to discuss one of those topics. The other one that I included, and we actually have just a minute or two, this is a MK Ultra was a real research program that actually was conducted in the military at Fort Bragg. Well, I tell you what, let me just skip that. But I would encourage you to, what I've included in that is there's a movie trailer. I think George Clooney was in the movie. There were several stars in the movie. If you see the clip, you'll think, wow, this is the funniest movie. It's a horrible movie. In fact, the only thing that's funny about the movie is the clip. And I think they took an hour and a half of a movie and found all the funny pieces and put it in a 2-minute movie, or put it in a 2-minute clip. But the one thing the movie does tell you is just how outrageous some of the research has been through the years and things that we thought we could do. Anyway, with that, let me stop and ask, are there questions? I know everybody's looking at, it's almost 7 o'clock, so he'll be quiet in 1 minute. But if there are no questions, I will give you one more chance. Are there any questions on this? So again, let's just wrap up with these two things. Again, finish your ResearchGate profile and get that started. If you want to search, you can start by searching for me or Dr. Zimmerman. That'll at least give you some insight into how to search, or some of your other professors. The folks in the business school, some have published more than others. So you may see, particularly the people in economics may have more papers that are out there, but and certainly finance has been busy. But it'll at least give you some understanding of how that system works. But do the quiz and do the ResearchGate profile. And I would tell you to please go ahead and get started thinking about what your question would be. And if you want to send me a sample question over the next couple of days, I think that would be a great place to get started. Please do not wait until Sunday night of next week to get started on most of this stuff. Next week will be a busy week. Okay? I don't have anything else, and I'll give you one last chance for questions.
Yeah, about the topic next week.
Yes.
So if we make a topic, that's going to be the final, like there's no going back?
There will be an opportunity to tweak it. So you'll, let's say you pick your question and you like it, and I tell you, I think that's a good question, and we clean it up a little bit. And then the next week, we will present that question. You'll do a PowerPoint presentation. It's going to be a really short one, but you'll present your question to the rest of the class. And during the next couple of weeks, you will start building on that research question. I will tell you, all of your assignments for the coming really the coming 8 weeks will be built around that research question. So if you early into this, if you decide I need to adjust this a little bit, or I need to go in a different direction, the sooner you can make that different direction change, the better off you're going to be, because otherwise there's a lot of work you may have to repeat if you wait 4 weeks down the road and say, this is useless, I can't finish this. I'll do my best to help guide you in a way that you won't get 4 weeks down the road and say, this is useless, I can't finish that. Does that help?
Yeah, that's perfect. Thank you.
Okay. Are there any other questions?
I'm just wondering if our research questions should be more geared towards the non-experimental research aspect of the project, or if it should be geared towards an experimental question.
I would encourage all of you to think non-experimental and think descriptive analysis or historical analysis. And the reason I would do that is there's some simplicity in it. Now, there will be a couple of group assignments that will be quasi-experimental, maybe true experimental, but it'll be really small and really confined and done just in a way to help you get a feel for what that means. Again, your question, your specific research, I would encourage all of you doing your paper to stick with something that's non-experimental, descriptive, historical, one of those types of analyses. Again, it's easier and it helps you understand the process. But I will give you, when we put you in groups, I will give each of your groups an assignment that will have some form of a small experimental design to it. And that's intended to help you understand experimental processes versus non-experimental. Does that help?
Yes, thank you.
Sure. Are there other questions? Okay, so again, you know where I'm at. If there's anything that comes to mind that you need to ask a question, please send me an email. I'll be glad to get back to you. I'll ask one last time, are there any other questions? Okay, well, I'm glad I got to see everybody tonight. And if I don't see you before, I will see you next week right here on Zoom. You all have a good night.
Me too.
Thank you.
Sure. Good night.